Bitcoin's liquidity is migrating onto layer 2s, but that migration exposes users to relentless on-chain tracing. Deposits and withdrawals become linkable, strategies are visible, and financial privacy erodes. That's the problem Zephyr aims to solve. Zephyr is a non-custodial privacy layer for bridged Bitcoin on Starknet. It lets users shield bridged BTC into a Merkle accumulator on-chain, generate zero-knowledge Stark proofs in the browser or an attested prover pool, and withdraw to arbitrary recipients without linking deposits to withdrawals. Secrets and nullifiers are generated client-side. The chain only ever sees commitments, roots, and proofs. Technically, the system uses Cairo smart contracts, a deposit contract to accept commitments and emit events, a Merkle anchor that stores on-chain roots, an on-chain verifier contract that checks Stark proofs, a nullifier registry to prevent double spends, and a withdrawal manager to release bridged tokens. Off-chain, an indexer builds the Merkle tree and a WASM Cairo prover runs in the browser to keep secrets local. The withdrawal path is atomic. Verify right-pointing arrow mark nullifier right-pointing arrow release funds, ensuring no race conditions. Important safety features include bucketized deposits, rate-limited root updates by relayers, time-locked upgrades, and multi-sig governance. Next milestones. Finalize client WASM prover and prover pool attestation, complete Cairo contract audits, deploy to Starknet testnet, integrate wallets for one-click private deposits, then scale roots and UI for production mainnet launch. Join us, test, and help harden the privacy layer for Bitcoin on Starknet. Redefine Hackathon. Welcome to Zephyr, private Bitcoin for Starknet. This is where Bitcoin liquidity meets modern layer 2 privacy, a non-custodial, zero-knowledge privacy layer that shields bridged BTC while staying fully composable with Starknet DeFi. On the landing page you'll find our core promise front and center, privacy without trust. A short tagline explains that deposits are committed client-side, proofs are generated in browser WASM or optional prover pools, and only commitments and Stark proofs are ever published on-chain. Below the hero you'll see 3 quick tiles: privacy guarantees, composability, and auditable roots. Privacy guarantees notes unlinkability between deposit and withdraw. Composability highlights how private BTC can be used in DEXs, lending, and NFT flows on Starknet. Auditable roots tells you the Merkle root is anchored on-chain for verifiability, while secrets stay local. There's a prominent call to action to try the testnet SDK, and smaller badges for docs, audits, and community links. We show a short animation that visualizes Bitcoin right-pointing arrow bridge right-pointing arrow Zephyr shield right-pointing arrow private L2 assets, illustrating how metadata is obfuscated while the system remains auditable. If you scroll down, you'll find a short roadmap and economic summary, the tokenomics and fee model, plus a security section listing third-party audits and a public bug bounty. Everything here is designed to build trust, open-source contracts, time-locked governance, and clear upgrade paths. When you're ready, click Connect Wallet to get started. First, connect your Starknet wallet. Zephyr supports Argent, Bravos, and other Starknet wallets. Connecting uses standard account abstraction. You sign and approve transactions. No secrets or private seeds leave your device. On the wallet page you can manage local secrets and identity commitments. Generate or import a per-device secret used to derive nullifiers and identity commitments. The secret never leaves your browser. You'll also see a compact key status panel that shows prover options, WASM health, and storage encryption state. There's a developer tab that exposes the worker post message API for proof jobs and progress events. Select the BTC on Starknet asset and enter the amount you want to shield. Click Generate Commitment. Zephyr computes a circuit-friendly commitment using Peterson and Poseidon hashes, and derives a nullifier to prevent double spends in the future. Inside the browser, a Cairo program compiled to WebAssembly builds the Merkle proof and generates a ZK Stark proving the commitment is valid. The wallet next prepares a Starknet transaction containing only the public commitment and proof. Your secret and raw amount are never submitted. When the deposit executes, the deposit contract updates the sparse Merkle tree and emits a new root. Chain observers can see an anonymous deposit event, but they cannot link the deposit to any future withdrawal. Withdrawals begin with the same private proof flow. Generate a proof of membership and spendability, then call the verifier contract on Starknet. The verifier checks the Stark against the anchored root, confirms the nullifier is unused, and atomically marks it spent while releasing funds to the destination. Withdraw page supports destination types, batch options for timing obfuscation, and urgency fees if you opt out of batching. All proof generation can happen client-side. Alternatively, you may use an attested prover pool for lower latency. Activity shows your local commitments and their on-chain status, proofs pending, roots referenced, and transaction receipts. The global activity feed shows anonymous deposit and withdrawal events, but no link to your identity or wallet. We highlight the use of Poseidon and Peterson hashes in circuits, sparse Merkle accumulators for scalability, and ZK Starks to avoid trusted setups. Starknet specific note: proofs are verified on Starknet using an efficient verifier contract. The anchored Merkle root is stored on-chain to enable public, auditable membership checks without leaking secrets. Amount bucketing via denomination pools, timing obfuscation and batched withdrawals, onion-routed relayers to hide IP metadata, and optional attestation for prover pools. Account preferences, prover options, and time lock or relayer selection for fee abstraction. Links and help to developer guides, circuit specifications, contract obese, and the worker messaging API.